6 minutes after 5, it is Capricorn FM, Limpopo's hottest frequency. It's time for us to get into hashtag Kagiso Radio Teacher.
This lesson is brought to you proudly by Kagiso Trust in partnership with the Limpopo Department of Education and Capricorn FM. Kagiso Trust, overcoming poverty.
Class is in session.
Ding, ding, ding.
Yeah, Rana, Pele, yeah, Rana. But it'll come soon, all right? So it's time for us to get into our catch-up lesson for today. We will be taking a look at Physical Sciences Term 1, Vertical Projectile Motion. And joining us to share the lesson with us, of course, is Mr. Tangwani. Coming back again here on the Just Drive for the second time to continue with the lesson. How are you doing, sir?
I'm fine.
You're fine? Very relaxed for today. I'm guessing it's not going to be a hectic lesson, is it?
Okay, very hot.
All right, the floor is yours, sir.
Okay, our topic is Vertical Projectile Motion, VPM. A projectile is any object upon which the only force acting is the force of gravity. Drop a stone and it falls. Does the stone fall at a constant velocity or is it accelerated? Does the motion of the stone depend upon its weight, upon its size, or upon its color? Of course, no. What goes up comes down. Why? If a resistance is ignored, objects dropped or thrown upwards or downwards are said to be in free fall. Free fall is defined as the motion of an object moving under the influence of gravitational force only. When we use the expression freely falling objects, we do not necessarily refer to objects dropped from rest. Objects thrown upwards or downwards and those released from rest are all falling freely once they are released. Any freely falling object experiences an acceleration directed downwards, regardless of its initial motion. We shall denote the magnitude of the free fall acceleration, also called acceleration due to gravity, by the symbol lowercase g, a small letter g. The value of g decreases with increasing altitude above the Earth's surface. At or near the Earth's surface, the value of g is approximately 9.8 meters per square second. Unless stated otherwise, we shall use this value for g, that is 9.8 meters per square second, when performing calculations. In this topic, we are going to neglect a resistance. Two objects dropped from the same height will hit the ground at the same time and with the same velocity. Emphasis: the magnitude of the free fall acceleration is known as the acceleration due to gravity, that is gravitational acceleration, and has a special symbol g. G has a value of 9.8 meters per square second. What does this mean? It means that the downward directed velocity increases by 9.8 meters per second each second. To put it another way, the acceleration is 9.8 meters per square second downwards. The upward directed velocity decreases at the rate of 9.8 meters per second every second until the object reaches the top of its flight, where the velocity is 0. When the object is projected upwards, it takes the same time to reach maximum height from the point of upward launch as the time to fall to the point of launch. This is known as time symmetry. The initial velocity with which the projectile is launched is equal in magnitude to the final velocity reached at the point where the object was launched. Several points about free fall worthy to note are: 1. G, by definition, is always positive. There will never be a problem that will use a negative value for G. 2. G is not the acceleration of free fall, but simply its magnitude. If we choose upwards as the positive direction, AY, that is vertical acceleration, equals negative G equals negative 9.8 meters per square second vertically downwards. It is AY that is negative, not G. A very serious misconception to be eradicated. 3. Gravitational acceleration is always directed downwards, in that gravitational force is always directed downwards, and acceleration is always in the direction of the net force, in keeping with Newton's second law of motion. 4. The movement and the progress of the projectile can be calculated by using the equations of motion. The equations referred to in this case are: 1. V final squared equals V initial squared plus 2A delta Y. 2. V final equals V initial plus A delta T. 3. Delta Y equals V initial delta T plus half A open bracket delta T close bracket squared. 4. Delta Y equals half open bracket VI plus VF close bracket delta T, where VI, the initial velocity in meters per second, VF, final velocity in meters per second, delta Y, displacement of the object in meters, A, acceleration in meters per square second, and delta T, time in seconds. Note well, in calculations, the negative sign means go the other way. That is, turn around. The negative sign belongs to the direction. To save using a bracket, we put the negative sign in front of the number. But the negative sign does not belong to the number. Another serious misconception to be strongly uprooted. In the case of time, a negative sign does not make physical sense, since it refers to a time before the object left the hand at t equals 0 second. So, the negative time answer is nonsensical. Problem-solving strategy. When solving problems, we use an orderly procedure as follows. 1. Read the problem carefully. Try to visualize the actual situation. Make a sketch if necessary. 2. Identify the quantities that are given in the problem. 3. Identify the quantity that is the unknown, that is the target variable, the one you have to find. 4. Select the equation or equations that will relate to the given and unknown quantities. 5. Make sure that the equations can be applied to the problem. 6. Write down equations needed to solve for the unknown quantity. 7. Substitute the given values into the equation and solve. Lastly, 8. Make a rough estimate to see if your answer is scientifically reasonable. Graph sketching and interpretation. In graph sketching and interpretation, mathematical knowledge is a primary commodity. Maths first, science will follow. 1. Velocity versus time graph. Write down the equation of a straight line y equals mx plus c. Exactly underneath, write down the equation of motion Vf equals a delta t plus Vi. Compare the two equations. You now see that y goes together with Vf, that a goes together with m, t goes together with x, and Vi goes together with c. In maths, we draw a graph of y versus x. In physics, we draw a graph of v versus t. Note well, a velocity versus time graph is a straight line. Note the following with regard to VT graphs. 1. Gradient m equals acceleration a, which is 9.8 meters per square second. 2. The y-intercept c equals the initial velocity Vi. 3. The shape now. If upwards is positive, then the VT graph is a straight line which slopes left. In this case, A, the gradient, is negative 9.8 meters per square second. And if downwards is positive, then the VT graph is a straight line which slopes right. Our A in this case is positive 9.8 meters per square second. 4. The area between the graph and the time axis equals the change in position, that is the location of an object relative to a reference point. 2. Position versus time graphs. Write down the general quadratic equation. Y equals ax squared plus bx plus c. When a is greater than 0, that is positive, the graph is concave up. It has a minimum turning point. When a is less than 0, that is negative, the graph is concave down. It has a maximum turning point. Now, write down the equation of motion. Delta y equals half a open bracket delta t close bracket squared plus vi delta t, where delta y equals yf minus yi. Therefore, yf equals half a open bracket delta t close bracket squared plus vi delta t plus yi. Therefore, we drop yf this time. We have y equals, f is dropped, y equals half a open bracket delta t close bracket squared plus vi delta t plus yi. Exactly underneath, y equals ax squared plus bx plus c. Write down y equals half a open bracket delta t close bracket squared plus vi delta t plus y initial yi. It becomes crystal clear that the y-intercept c equals the initial position yi. B equals the initial velocity vi. In maths, we draw a graph of y versus x. In physics, we draw a graph of y position versus t, the time. Let's check the shape. If upwards is positive, then the yt graph is a parabola which is concave down. If downwards is positive, then the yt graph is a parabola which is concave up. Note the following with regard to yt graphs. Gradient equals velocity. The y-intercept c equals the initial position yi. Acceleration versus time graph. The acceleration is a constant 9.8 meters per square second, always directed downwards. The shape now. If upwards is positive, then the AT graph is a horizontal line parallel to the time axis below 0. A equals negative 9.8 meters per square second. If downwards is positive, then the AT graph is a horizontal line parallel to the time axis above 0. A equals positive 9.8 meters per square second. Some useful formulae. Area of a triangle equals half base multiplied by perpendicular height. Area of a rectangle equals length multiplied by width, that is the breadth. Area of a trapezium equals half, open bracket, sum of the parallel sides, close bracket, multiplied by the perpendicular height. We are also expected to be able to write down the equations for position versus time and velocity versus time graphs, but only for one-dimensional projectile motion. CAPS document, page 103. The general equation for the position versus time graph is y equals half a, open bracket, delta t, close bracket, squared, plus vi delta t plus yi, where yi is the position at t equals to 0 second. Therefore, y equals positive or negative, that is plus minus 4.9 t squared, plus minus vi delta t, plus minus yi. your sign conversion determines whether it is a plus or a minus sign, which goes together with 4,9, together with VI, together with YI. The general equation for the velocity versus time graph is V equals A delta T plus VI. Therefore, V equals plus minus 9,8 T plus minus VI. Your sign convention determines whether it is a plus or a minus sign, which goes together with 9,8 or VI. Time is the only constraint in this lesson presentation. We have 5 activities to go through. Let us start with activity 5. Activity 5. Are you ready to take the activity? Okay. Right. A 400 grams bullet is thrown vertically upwards from the ground with a velocity of 28,69 meters per second. A 400 gram ball is thrown vertically upwards from the ground with a velocity of 28,69 meters per second. The ball takes 5,84 seconds to return to the ground. 5,84 seconds to return to the ground. On striking the ground, the ball bounces and reaches a height that is exactly half the maximum height attained in the throw. Neglect the effects of air resistance. 5.1. Define the term free fall. 2 marks. Define the term free fall. 2 marks. The answer is motion of an object moving under the influence of gravitational force only. Only is a key word. Its omission makes the definition inappropriate. 5.2. Draw a labeled free body diagram for the ball whilst ascending, that is moving upwards. 2 marks.
Alrighty, so we're gonna hold it there for now. We're gonna be getting into the 5:30 Capricorn FM news headlines with Nhlamulo Marule, and then Kamorelo Namalane will follow shortly with Capricorn FM sports.
The coronavirus has spread quickly around the world. It moves with stealth and it's deadly. And for now, isolation, constant washing of hands and sanitizing are the only effective means to bring it under control. To protect us all, South Africa has been locked down. But this will only work if every one of us does our part to remain isolated and supports all the measures our government has put in place. To assist us, the South African National Defence Force has been deployed to share the enforcement burden, save lives, build trust, and work with the citizens. The SANDF's presence is reassuring. They are here to protect the nation against harm. And right now, that harm is the coronavirus. Assist the SANDF by giving them your full support, and they'll support and protect you. Every Monday just after 7, the SANDF and Capricorn FM will bring you the SANDF Coronavirus Update. The SANDF and Capricorn FM. We're stronger together.
News headlines on Capricorn FM.
In news making headlines, Democratic Alliance Shadow Minister of Higher Education, Sciences and Technology, Professor Belinda Bozzoli, says they will not support the reopening of schools unless those schools are ready, and they will be using a criteria set to determine the readiness of each school. Meanwhile, the Department of Small Business Development has announced that it has closed the first window for businesses to apply for relief during the COVID-19 pandemic. And Minister of Police, Begicele, has indicated that there there has been no increase in gender-based violence cases since the start of the lockdown, as reported in the media. Your final bulletin at 6 p.m.
Capricorn FM Sports. On and off the field, we've got you covered.
And now for your final look at your sports for today, Mamelodi Sundowns coach Peter Mosimane has revealed the reasons behind his decision to come to an agreement on a new contract that will keep him at the club until 2024. Sundowns and Mosimane have been negotiating for months in the lead up to his renewal, which was confirmed by club president Petrus Motsepe. It has been speculated that reasons for the delay had to do with finances, which that 55-year-old quickly put to bed, while another had to do with the special clauses in his contract. Ultimately, the two parties found one another, and Jingles has since opened up about what motivated his decision.
I'm happy that we have came to where I wished we could, because I had no reason why we should not continue. I've always said it. Yeah, as I said, you must always stay where you are loved. You know, players are with me. I've got a dressing room. I've got the people singing for the club, singing for me. Why should I leave? Why do I want to leave? And if the president says that he wants me to be staying here for long, the president and the board saying they want me to stay for long, and I know the players want me to stay also, to be honest. So I'm happy. I'm happy to be here, and I'm happy to start the next 4 years on top of the 7.5 years we have.
Meanwhile, in rugby, Wallabies forward Isaac Roder and two teammates are parting ways with the Reds after they were suspended for refusing a pandemic-prompted pay cut. Rugby Australia said that Roder, Harry Hawkins and Isaac Lucas had moved to terminate their contracts over the increasingly bitter pay disputes. The trio had rejected a deal that saw the country's professional rugby union players swallow a 60% pay cut over 6 months to help the game avoid insolvency. The agreement covers almost 200 players and was reached after 3 weeks of discussion between Rugby Australia and country's 4 Super Rugby teams, as well as the Rugby Union Players Association. And finally, in the English Premier League, Steve Bruce has warned Danny Rose that he has to be careful with his opinions following the fullback's concerns over footballers returning to action amid the coronavirus pandemic. The Newcastle United fullback on loan from Tottenham Hotspur claims he fears players are being treated like leopards as the Premier League pushes forward with the experiments in a desperate bid to complete the season.
People are suggesting we should go back to football, basically like we're guinea pigs or lab rats, that we're going to experiment this phase and see if it works or not. And I can just imagine people at home just saying, well, they earn this amount of money, so they should be going back. So, do you know, for stuff like that, where I just think this is not worth the hassle. I could be potentially risking my health for people's entertainment, and that's just not something that I want to be involved in.
And while claiming he would respect the wishes of players not comfortable with the return to football, Bruce has admitted to discussions with Rose on trying to be less harsh of the circumstances of his opinion.
He's entitled to his opinion. And for Danny as well, I don't think there's been anybody more generous towards the cause than Danny, and which is fair play to him. You know, he's tried to keep it quietly and got on with it, but he's spent a hell of a lot of money, the fella, to the NHS and donated his time. So he's got his opinions, and he's just got to be careful with them and careful which platform he puts them on.
And finally, Bruce, though, has tried to ensure players of the safety measures in the force at the club's training grounds, with the Toon boss claiming that following strict guidelines, they couldn't be more safer.
We've done now 2 days, and I think the most important thing is the steps that everybody has made, especially our club as well, in what they've done to set it up. I mean, we couldn't be more safe. I mean, we arrive at a certain time, we park 3 cars away from each other. The players come in stripped. Their temperature, they take their own temperature before they arrive on an app, so we have to produce that, and then we have our temperature taken again.
And this is all your sports from me today. More on the Sports Precinct with Gwena Moabelo at 7. I'll be back with more tomorrow morning on the Saturday Breakfast with Fosi Alpha. And for more updates, follow at Capricorn FM News on Twitter. And for Capricorn FM Sports, I am Kamagelo Namalani.
Keeping you up to date with the latest sports news. Capricorn FM Sports. Listen to Capricorn FM online on capricornfm.co.za.
This lesson is proudly brought to you by Kagiso Trust in partnership with the Limpopo Department of Education and Capricorn FM. Kagiso Trust, overcoming poverty.
25 minutes heading to 6. We're still continuing with our catch-up lesson. Hashtag Kagiso Radio Teacher. Mr. Tangwane is here, of course, and the lesson for today is Physical Sciences Term 1, Vertical Projectile Motion. You may continue, sir.
Okay. Let us continue with activity 5. 5.2, Draw a labeled free body diagram for the ball whilst ascending, that is moving upwards. 2 marks. The answer is draw a big enough dot. From the dot, draw a downward pointing arrow. Label it weight or gravitational force. Weight or gravitational force. We do have a correct free body diagram now. Look at it. 5.3, write down the following. 5.3.1. The time taken for the ball to reach its maximum height, 2 marks. The time taken for the ball to reach its maximum height, 2 marks. The expected answer is by time symmetry, delta T equals half. Delta T equals half, open bracket, 5,84, close bracket. A calculator gives us 2,92 seconds. 2,92 seconds. Time up equals time down, of course, in the absence of air resistance. 5.3.2. Write down the acceleration of the ball at its maximum height. The acceleration of the ball at its maximum height, 2 marks. The answer is A equals 9,8 meters per square second downwards. A equals 9,8 meters per square second downwards. Free fall acceleration is always 9,8 meters per square second directed downwards. Free fall acceleration is always 9,8 meters per square second directed downwards. 5.3.3. The velocity of the ball at its maximum height, 1 mark. The velocity of the ball at its maximum height, 1 mark. The expected answer is V equals 0 meter per second. V equals 0 meter per second. The reason as for Y0 needs calculus, maxima and minima. The rates of change. Forget you not that V equals dy dt. So, if Y is maximum, V prime is 0. 5.3.4. The acceleration of the ball 5 meters above the ground whilst ascending. The acceleration of the ball 5 meters above the ground whilst ascending, 2 marks. The answer is A equals 9,8 meters per square second downwards. This is repetition, okay? The free fall acceleration is always 9,8 meters per square second downwards. 5.3.5. The velocity of the ball at the instant it strikes the ground, 2 marks. The answer is V equals 28.69 meters per second downwards. V equals 28.69 meters per second downwards. By symmetry, we know that the speed at which the ball returns to the point of projection is the same as the speed at which the ball was thrown up. Velocity needs direction for full specification as it is a vector quantity. 5.4. Calculate the 5.4.1 greatest height attained by the ball, 3 marks. Greatest height attained by the ball, 3 marks. Take upwards as the positive direction for all calculations in this activity. The solution now. Do not forget to love physics with chemistry, the LPWC approach in all the calculations. L, list the data. VI equals positive 28.69 meters per second. Delta T equals 2.92 seconds. A equals negative 9.8 meters per square second. The unknown or target variable is delta Y. P. Pick an equation. Delta Y equals VI delta T plus half A open bracket delta T close bracket squared. W, write down the known values into the equation. Therefore, delta Y equals open bracket 28.69 close bracket open bracket 2.92 close bracket plus half open bracket negative 9.8 close bracket open bracket 2.92 close bracket squared. A calculator gives us delta Y equals 41.995 meters. Thou shalt paraphrase. Let us paraphrase. The height attained by the ball is 41.995 meters. C. Check each line quickly for making sense. Correct rounding off as per question paper's instruction number 10, which says round off your final numerical answers to a minimum of 2 decimal places. And for correct units, of course, we deserve 3 full marks. 5.4.2, the velocity of the ball the instant it bounces off the ground, 6 marks. The velocity of the ball the instant it bounces off the ground, 6 marks. Let us solve this problem together. After bouncing, the ball rises to a height of 20.9975 meters. 20.9975 meters. That is half of 41.995 meters. Our motto in calculations is love physics with chemistry. List the data. VF equals 0 meter per second. A equals negative 9.8 meters per square second. Delta Y equals positive 20.9975 meters. The unknown or target variable is VI. Pick an equation. VF squared equals VI squared plus 2A delta Y. Write down the known values into the equation. Therefore, 0 squared equals VI squared plus 2, open bracket, negative 9.8, close bracket, open bracket, 20.9975, close bracket. A simple algebraic manipulation gives us VI squared equals 411.551. VI squared equals 411.551. Taking square root of both sides from a calculator, we get VI equals plus minus 20.29 meters per second. Our sign convention, which is take upwards as positive, drives us towards choosing VI equals positive 20.29 meters per second. Always paraphrase. The velocity of the ball is 20.29 meters per second upwards. Check each line quickly. I won't repeat this one, is check. The last one after every calculation is check. 5.5. Describe in terms of velocity, acceleration, and gravitational force the motion of the ball from the moment it is thrown until it hits the ground after 5.84 seconds. 5 marks. Describe in terms of velocity, acceleration, and gravitational force the motion of the ball from the moment it is thrown until it hits the ground after 5.84 seconds. 5 marks. Let us give the correct response in this case. When the ball is projected upwards, its initial velocity is at maximum, but it slows down constantly at a rate of 9.8 meters per square second due to the gravitational attraction of the Earth until it reaches the highest point in its path or trajectory. It stops momentarily, v equals to 0 at this point, and then starts to accelerate downwards constantly at 9.8 meters per second squared. Its velocity increases until it hits the ground at a maximum final velocity whose magnitude equals the magnitude of the initial upwards velocity. Okay? Thanks. 5.6. The average net force exerted by the ground on the ball as it bounces is 103 newtons. 5.6.1. Write down the average net force exerted by the ball on the ground. 2 marks. Average net force exerted by the ball on the ground. 2 marks. The answer is 103 newtons downwards. Remember, force is a vector quantity, thus direction is needed for full specification. 5.6.2. Write down the name of and state in words the physics law applied in answering question 5.6.1 above. 3 marks. The answer is Newton's third law of motion, the statement of which is When one body exerts a force on a second body, the second body exerts a force of equal magnitude in the opposite direction on the first body. 5.6.3. Calculate the time for which the ball and the ground are in contact for marks. The solution is the change in momentum of the ball is caused by the force of the ground on the ball. The ball's change in momentum is equal to the impulse F net delta T on it. Let us now apply our motto, LPWC approach, love physics with chemistry. List the data. M equals 400 grams, which is converted to 0.4 kilograms. VI equals negative 28.69 meters per second. VF is positive 20.29 meters per second. F net equals positive 1.103 newtons. The unknown or target variable is delta T. Pick an equation which is F net dot delta T equals M open bracket VF minus VI close bracket. Write down the known values into the equation, that is substitute. Therefore, open bracket 103 close bracket delta T equals open bracket 0.4 close bracket open bracket 20.29 minus open bracket negative 28 minus 69 close bracket close bracket. A calculator gives us open bracket 103 close bracket delta T equals 19.592. A simple algebraic manipulation gives us delta T equals 19.592 divided by 103. Again, a calculator gives us delta T equals 0.19 second. The contact time is 0.19 second. Check. Always check. 5.7. Draw a velocity versus time sketch graph for the motion of the ball from the moment it is thrown upwards until it reaches its maximum height after the bounce. 7 marks. Clearly indicate the values of the following on the graph. First bullet, initial velocity. Second bullet, the velocity when it hits the ground. The third bullet, the velocity when it leaves the ground during the bounce. Fourth bullet, the time when it reaches the maximum height. The fifth bullet, the time when it strikes the ground. The sixth bullet, the time when it leaves the ground. Let us answer this question. Listen and follow the instructions in answering this question. Listen very attentively, please. Draw a 12 centimeter long vertical line, double-headed arrow. Right? From midpoint of the vertical line, draw a ray. That is an arrow to the right, about 12 centimeters long. Label the vertical axis velocity in meters per second and the horizontal axis time in seconds. Mark a point above 0 on the vertical line. Label it 28.69. Below the 0, mark a point on the vertical line. Label it negative 28.69. Mark 2 points, 2.92 and 5.84 on the time axis. From the negative 28.69 mark, draw a dashed line segment to the right to meet a vertical dashed line segment drawn from 5,84. The two lines meet at a point 5,84 and a negative 28,69. Starting from the 28,69 mark, draw a solid line segment passing through the point 2,92 on the time axis and it touches the point 5,84 and negative 28,69. Add 0,19 to 5,84 to obtain 6,03. Just after a centimeter from negative 5,84 on its right side, from 5, not negative, 5,84 on its right side, mark a point 6,03 on the time axis. Draw a vertical dashed line segment to meet a horizontal dashed line segment drawn from 20,29, a point below 28,69. From a point below 6,03 and 20,29, draw a solid line segment parallel to the first line segment just to touch the time axis. The graph you see below is what we expect. Look at it. Constant practice and revision will help you to discover and eliminate fundamental and habitual errors, resulting in you approaching the final examinations with increased confidence. Perseverance, dedication, courage, and sacrifice make an enormous positive contribution towards your achievements. If you work at being successful, you will become successful. They say, where there is a will, always there is a way. Glory be to God, from whom all blessings flow. Hallelujah. Amen.
What a way to sum it up.
Amen.
Amen.
Aye.
It's a beautiful way to wrap up a lesson. I think teachers should just adopt that. Rapele before,
and after maybe.
Especially in an exam. I think people might use prayer just after going through a mathematics exam or a physical science exam, just to know that things are going to be okay. All right? Mr. Tangwane, for a lovely lesson, Physical Sciences Term 1, Vertical Projectile. Yeah?
Do you remember that this lesson was proudly brought to you by Kagiso Trust in partnership with the Limpopo Department of Education and Capricorn FM? Kagiso Trust, overcoming poverty.
And that is how we wrap up